Hello everybody, today we'll be doing merge k sorted lists. So you are given an array of k linked lists, and each linked list is sorted in ascending order. So let's check out example 1. So here in example 1, as part of our understanding, I have an @ sign. Okay, so let's check that out. We have an input, output. We are going to merge each linked list. So a linked list has 1, 4, 5, 1, 3, 4, and a 2, 6. So we're going to merge each two linked lists together, each of the linked lists together to form this item. And we're going to do this for an empty list as well, and also a empty list of empty lists, just blank items. So what's going to happen here is, pretty simple. What we're going to do here is we could, if our time complexity is n times k, then it's not hard at all, because we just have to merge each k for each list, and n for each node. Then we can just merge these k times n times, because we merge this one with this one. Then we take these two together and we merge it with this one here, and that way we can do this n times k times, because we have to do this number of lists that are available. However, we could speed this up and get a time of n log k, because we merge each two pairs together, and that way we reduce the number of pairs. Let me show you what I mean. So let's say here's 1, 2, let's say here's 1, 5, 10, 15, 20, and 25, 20, 30. Okay, each of these are head pointers, right? What happens is that if you merge these two together, 1 and 5, 10 and 15, 25 and 5, right? 20. So 10 and 15, 20 and 25. And we have 30, because there's nothing to merge here. If we have these, what happens is that we can merge 1, 5, 10, 15, right? And that's so much faster, because we only have to do log k times. We only have to merge the same items k times, log k times, because that's the length of the tree, because we reduce the number of lists by half every single time. So we have 20, 25, 30. With that, the last time we merge is the combination of these. So that's how we're going to get n log k times. So what's the space-time complexity about this? The space-time complexity is actually pretty small. Well, what we're going to do is store everything into, let's merge every two pairs together. And that's going to be O of n space. Because what we're trying to retain here are, we're going to have each head. And each time we retain, we create this new list. We're going to have half the number of heads, half the number of lists, right? And so, there's still pointers though, I believe. So it's still going to be O of k actually. O of k, number of heads available to us. So O of k space. Because what we're doing here is we're storing the next list to be processed every single time, as you can see here. Okay, with that, I think we have our understanding about what we're going to do. What we're going to do now is make a match, and the match is going to be, we're going to do merge sort, as intended by the title. And so here's the plan. What we're going to do is merge while the list is greater than 1, merge each pair of head nodes and return list. That's it, right? So how do you merge items? Well, How to merge? Well, what we're gonna do is take the lesser item, lesser value, head, between two lists and increment. And set current pointer to next to merge. And increment the head pointer. Lastly, get the remaining linked list from the remainder of the linked list, if there is any. So here's what I mean by that. So we make a dummy node. So say we have a dummy node, and we're going to point to one of the either two linked lists, right? Let's like we have list 1 and list 2. So we have 1, 4, 5, and we have 1, 3, 4. This is basically 2 problems in one. And we're going to take whichever, like let's just say I and j. Of course, this is not necessary, but we're going to take the lesser of the two. So we take lesser of the 2, push it up. We take the lesser of the 2, we push it up, and so on and so forth. And we just keep pushing all these items onto our linked list. And we're going to return the combined linked list. And what I mean by the last part is that when this goes out of bounds, this is still not finished yet. We're going to take the remainder of this linked list and just append it to the end. See, as you can see that if we have infinite items after like that much, like we'll take all of this and just append it straight to the end of our linked list, right? We don't want to just keep incrementing slowly. So let's just finish it up and just pop that on there. And with that, that's how we merge lists. That's how we're going to merge k-sorted lists. If there's nothing else, we're going to start implementing this now. So here we go. This is going to cause a problem a little bit later if we don't comment this out. So first things first, what we're going to do is do a while loop. As we said, we're going to do while length of list is greater than 1. We're going to create a new list, empty list, or temp list, you can call it. Let's call it temp list. That we're going to hold new values, new heads in. Okay, so and we're going to increment every pair, right? So for I in range of starting from 0, going to the length of list by 2. So list 1 is going to be the the list at I, and list 2 is going to be list at I plus 1. Of course, there might be I plus 1 goes out of bounds, and so we need to make sure I plus 1 is less than length of list. Otherwise, let's return none, where there's no head there. So what we're going to do now is we're going to merge 2 lists and put them into a temp list. And we're going to take list 1 and list 2. Afterwards, we're going to put the list is going to be equal to the temp list, and we're going to keep churning until we run out of items in our list, and we're going to return list at 0, the only one item. So let's define our merge list function. So self list 1, list 2. If we want to be more, like better about this, we're going to put this in. And also, I don't think we've managed all the edge cases yet. I've just recalled that there might be empty lists, like there might be no list. So if not list, like there's nothing in here, return none, please. Okay. So with that, we have our merge list. Let's make our dummy node, and equals to cur, and equals to like just random list node, right? We have done this so many times already, I think, together, if you've watched in my previous videos. But you know, if not, we can, you know, just talk about it again. So here we go. While list1 and list2, what happens is that cur, if cur list1 dot val is less than list2 dot val, then what we're gonna do here is list1 dot val, actually not val, dot next, list1 is equal to list1 dot next, and cur is equal to cur dot next. Of course, cur dot next is of course equal to list1 first. Next, else we're going to take cur dot next is equal to list2 equals list2 dot next, and cur equals cur dot next. With that, we have completed our how to merge. We made a dummy node. We take the lesser of the two, and we set the current pointer and increment the pointer. Lastly, we append the remainder. So if list1, right? What happens here is that we're gonna append this to the end of our current dot next. Else, we did not finish our line of dot. Else, current dot next is equal to list2, because yeah, list one doesn't exist. List2 must exist. I mean, they could both end at the same time, but that's not possible, right? Yeah, that's not possible. Okay, so return our dummy node dot next. And with that, I think we are pretty good with our code. We have basically completed this problem. Let's run the code. And yeah, we're good to go. Let's submit. And yes, perfectly done. Anything else? Evaluate? Well, based on evaluation, what we're going to do here is that we have, well, O of n log k, because we did exactly what we intended to do. And we have a O of k space, because we needed to retain that many heads. So it was exactly as predicted as in our understanding earlier. For k heads in temp list, to go over n items k log k times. That's it. Yeah, very simple problem. It says it's hard, but it gets pretty easy to do with when you've done enough linked list problems. So yeah, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.